Hi everyone, can you hear me? Welcome to Science Gallery London. We're a place to grow new ideas across art, science and health. I know there's quite a few people who are yet to come, so can I please encourage you in the rows to gather together in the middle? Sorry, I know it's Britain and maybe you don't like to do this, but for the sake of our latecomers, it would be amazing if you could just huddle in to the centre a bit more. Thank you. Thanks so much. So I'm Jen, I'm head of programming here at Science Gallery London, and it's my great pleasure to welcome you to the first event in our Quantum Untangled season, which started on Tuesday this week. So you're in for a treat. We have an amazing lineup. But before I hand over to Lily, I'm going to just do some quick housekeeping notes. So if you need the loo, please feel free to go. It's just out the back, up the stairs the way you came and on the right. And just to say, we're not planning any fire alarms today. So if you hear an alarm, it means it's time to leave the building. And you do that by going up these stairs on my left and out the back of the theatre. Myself and Karen, our mediator, will be here to guide you if that happens. So what I'm so pleased to do right now is hand over to Lily Jencks from the Cosmic House to introduce the event. Thank you.
Hi everyone, we're thrilled to be here today, and thank you Jen for the invitation. I'm Lily Jencks, I'm Keeper of Vision at the Cosmic House. It's a relatively new cultural institution in West London, and there we go. In a grade 1 listed 1970s postmodern architectural manifesto of a house designed by Maggie and Charlie Jencks. The project we're here to discuss today is in part a reaction to the house and the ideas within it, how we orient ourselves to the universe, try to understand it, its most fundamental forces, and find meaning in our place within it. I have some slides flipping through here to introduce the house. This is the entrance, which is the Cosmic Oval, a vestibule, a hall of mirrors. It's an entrance like an appetizer for a meal, getting you used to the ideas and the concepts that you're going to find throughout the rest of the house. Painted around the ceiling is this cultural history frieze. It's a painting of 12 figures from across history and geography, sitting as if they're eating at Leonardo da Vinci's Last Supper, discussing ideas across space-time. The figures in the frieze sit under a night sky of stars and whirlpool galaxies, a small selection of the hundreds of billions of galaxies that we see in our observable universe. The character list comes from Charles Jencks. They're writers, poets, architects, scientists, historians, and philosophers who influenced him as he defined the movement postmodernism, a movement of which he was the protagonist and a figurehead, a historian, and eventual eulogizer. It's both important who the figures are, from Imhotep, Pythagoras, to the Emperor Hadrian, John Donne, Borromini, to Prince Ito, Thomas Jefferson, to Hannah Arendt. It's also not exactly important who they are, precisely, because they represent, or stand in for, or distill the intellectual thought and ambition evolving over time that created postmodernism. They stand on the shoulder of giants, like the evolution of discoveries in science, as paradigms shift paradigms. It's an evolution of cultural thought, of which this group of people is a consolidation, a canon, representing much more than themselves. He's trying to get to the kind of ultimate particles of postmodernism. You can think of these figures as strange attractors, containing a multitude of ideas, consolidating patterns of thought that circulate around their main theories and published papers. In their assembly, as they congregate for a cosmic supper, they symbolize humanity's quest for understanding architecture, philosophy, art, and science. Just to introduce Charles briefly, he was an architect, historian, writer, and a landscape designer who designed many projects that really looked into cosmology and represented cosmological ideas as landscapes that we could contemplate these thoughts in. This is the Garden of Cosmic Speculation in Scotland, where Professor Higgs visited. He's a local cosmologist in Edinburgh, standing on the Black Hole Terrace here with Rolf Hoyer from CERN behind him. And the Croik multiverse, and several other designs inspired by contemporary physics. Charles wanted to create environments in which to contemplate the biggest questions we face. Where are we going? Who are we? And where are we going to? Coming back to the Cosmic House, we commissioned the writer Ella Feiner to respond to the frieze in the Cosmic Oval as part of a series of projects we're doing this year on postmodern cosmology. The result is the book launched today. Very excited to launch the book here. Janna's holding. And we'll be discussing it with Ella Feiner and Janna Levin. Let me tell you a little bit about the book, first of all. There are 6 essays and accompanying sleep songs. Seven essays, sorry, it does say the 7. 7 essays and accompanying sleep songs written using a complex mesh of quotations from the figures as if they're in conversation. The Cosmic Oval Frieze is a kind of diagram of history, and Ella's essay is a kind of embodiment of that history. But clearly writing history is not a science, even when writing this history of science. Often writing about science itself is a kind of history writing, and we can see that in several of Janna's incredible books about the paradigm shifts that accompany key scientific discoveries about gravitational waves, extra dimensions, and black holes. Also, when we look to the universe, we're looking back in time, right? When we use physics to understand ultimate particles, we're telling the story of the evolution of 14 billion years, from the most simple elements to the complex world we see today. Imagine that story. Think about it for a second, full of miracles and paradigm jumps, right? From the Big Bang, to the sequence of supernova as elements evolve to more complex chemicals, compounds and minerals, consolidating into planets and stars. And this planet, which alone has the force of, at the moment, as we know, so much as we know, the force of tectonic plates, which evolve minerals in extreme conditions that somehow create single-cell organisms that are alive, slowly becoming multicellular organisms, animals, and then us, conscious beings, that can contemplate that story itself. So to set up that incredible journey and to take us on the journey of cosmology, history, and our search for meaning, I'll introduce our guests. Ella Feiner's work spans writing, composing, and curating, with a particular focus on how bodies acoustically disrupt, challenge, and change power relations. Her research frequently queries the ownership of cultural expression, often through collaborative projects that center listening as a practice of deep attention and reciprocity. And Janna Levin, a distinguished American theoretical cosmologist at Barnard College, a writer who brilliantly bridges the arts and science, as well as a hard scientist who always follows the chalk. She holds a PhD in physics from MIT, although I hear that she started with a degree in philosophy before switching to physics, thankfully for us, because she's now written several books, both a history of science and a novel. After the conversation today, we may have a response from Tony Milligan, who I don't yet see in the audience. If he's here, I will introduce him. He's a professor at King's. So to introduce the book and to start our conversation, we were going to read one of the sleep songs from the book. I'll put it on stage. And Ella, if you start, we're each going to take a verse, and then we'll dive into the conversation. So.
Yes. Without any kind of introduction of what this is, I'm just going to dive in. If everything is moving, here is not here. Even when there is a here, it is not exactly here, but still an elsewhere. I am here in the night, a night composed of nows and thens and some days. And you, fellow traveller, are with me, your speech still shifting the dark air. Everything is moving. We are standing outside the door to the house, listening to hushed conversation coming from inside, catching sentences, little drifter, fugitive across vocal registers. Distant galaxies are on the move. They are all rushing away. A question from inside, why are we here, dissolves into deep breathing. Many bodies inhaling, exhaling, like waves breaking in and out of time. Anticipating the future is as unavoidable and commonplace as breathing. This soft breath of 12 people at dinner or sleeping. They are both, I whisper, and you mouth magic without making a sound.
If everything is moving, here is not there, not exactly here, still and elsewhere. I am here in the night, a night composed of nows and thens and some days, and you, fellow traveller, your speech still shifting the dark air. Everything is moving, outside the door, listening, hushed from inside. Little drifter, distant galaxies move, all rushing. Why are we here? Dissolve deep, breathing bodies as waves breaking in and out of time. Anticipating the future as breathing, soft breath of 12 people at dinner or sleeping. I whisper, they are both. You mouth, magic, without a sound.
If everything is moving, here is not here, not exactly here, still and elsewhere, nows, thens, some days. Everything is moving, little drifter, distant galaxies move, all rushing, here, anticipating the future as breathing. Thank you, Ella.
Thank you. That's the first time I've heard them spoken out loud. I mean, they have been sung. They have been, and that's the strange thing, is that some of these sleep songs that are part of this essay have actually been set to music by Lina Lapalite and a group of amazing musicians, and so I can't help but hear that rhythm when I read it. And we were talking about that before, kind of the rhythms that stay with you, that you embody so deeply just from hearing them.
I mean, even reading it for the first time, I heard a song.
Did you?
Right, it feels like a composition.
Yeah. Oh, that's great.
Like a musical composition. Yeah.
Well, I thought we might start the conversation thinking about time and how time has influenced both of your work very much through very different routes, and time is very much in that first sleep song, both in the rhythm of how we embody it, but also very much in the words themselves. But we might start with Janna and ask you, Janna, if you can talk to us a bit about how we can understand time now. How do contemporary cosmologists understand time? It has changed a lot, our understanding of time and space-time, and there have been a series of paradigm shifts in our understanding of time, but are we still, how do you think about it now?
Well, I mean, my own notions of time are kind of ever evolving, but one idea that struck me while I was reading the book and I was imagining coming here is I was thinking about the relativity of time and how there's a sort of misunderstanding about that aspect of relativity, because there's a sense in which the theory of relativity was really extremely adhering to an absolute. Einstein discovered relativity by imposing an incredibly severe constraint on himself, which was to respect the constancy of the speed of light. And if you think about that, the constancy of the speed of light is absurd. It's absolutely absurd. It's not possible. So every physicist alive at the time was trying to say light must be relative and not constant, because it makes no sense. If I'm running at a light beam at nearly the speed of light, it is still coming at me at the speed of light. That seems impossible. It makes no sense. But what he had to do to make that true was break time and break space. And everything else had to yield in order to respect the constancy of the speed of light. So it doesn't exactly answer your question, how do I think of time, but it did make time malleable. And it meant it had to be different for me running at the speed of light than for Ella sitting still relative to the source if we both still saw the speed of light the same. Our times had to yield. So I think that that's a very dominant way that we think about time now. All else has to respect the speed of light.
Could you tell us a little bit about how Gödel's models of time, his conversations with Einstein, and what the impact of that might be in terms of time?
At one point, Einstein said, I only walk to the Institute these days for the pleasure of Gödel's company. So they would walk in Princeton to the Institute every day. So Gödel was a mathematician who had a Platonism. He believed that math existed out there in the world. He was really like a Platonist. He wasn't so sure about the rest of this. He was kind of maybe a paranoid schizophrenic. He wasn't so sure about the reality of you or his wife, but he was sure about the reality of a math circle. But Gödel showed Einstein that in the context of his own equations, Einstein's equations, that Gödel could imagine a universe that was spinning, not like the universe that we live in, which is expanding, which you refer to with the galaxies, but a universe that was spinning, that you could find what's called a closed time-like curve, that it would be possible to travel on a path and come back to a time before you left on that path. And Einstein did not believe that was possible until he saw Gödel's solution. So time travel is completely possible in the context of Einstein's theory. We just don't think it's consistent with other forces like quantum mechanics. But Gödel, I believe, was the first one to prove to Einstein that you could have these closed time-like curves and travel back in time.
I really love the image of companionship in that though, as well. And actually how much, so I have to just say I am such a massive fan of Janna's work that I might just have to take a moment. Because actually part of this fandom is about the way that you write about relationships of incredible incredible discovery and explanation and experimentation through companionship, friendship, the kind of pushes and pulls of desire in terms of what one wants to kind of find out, and even beyond one's own lifetime. And in Black Hole Blues, that's just so explicit in the relationship of all these people working together. And so that image of and finding each other as well, finding each other through people talking about who's working on different things at whatever particular time, like the matter of also circumstance, amazing chance. It is almost a bit like magic sometimes. And so then that image of the two figures loving each other's company, because also that's where I think the most amazing ideas and study comes from, is also just the pleasure in each other's company. So I just wanted to say that in relation to that, in relation to what you were saying about time. Go. Sorry.
I'd love you to talk about that in relation to the companions that you've written, talking to each other across time in the Cosmic Oval.
Yeah, I'm wary that I don't want to over-explain things, because I think actually a part of what is so brilliant about so brilliant about having Janna here is that, I think Janna, in your work, and I very much take this on myself as I write is not wanting to like over-explain things, break things by over-explanation. And of course, there are so many ways to explain things, and even just this morning, Janna sent an incredible, long scientific paper written in collaboration with several other
I said to only
brilliant
look at the
scientists.
pictures, though.
No, I know. I was really grateful you did. I was so grateful you did, because what it did is it reminded me not just of the many languages we use for explanation, and how, you know, scientific this kind of very, very like hard science with all the maths in it is one way of reaching a particular audience, but that we might also, you know, as those, I say we, and there's a lot in the book about we and who's claiming to be we, but how I approach that and what kind of meaning I can even glean from it. And there is actually a brilliant work in the exhibition upstairs where a group of artists have taken a scientific paper and just taken out the parts that speak to them, that are scientific, that are kind of poetically speak to them. But about the companionship of the book, not wanting to over-explain it, I did respond to this cosmic oval in the Cosmic House, which is a group of 12 figures who Charles Jencks and Maggie Jencks together chose in this rather kind of interestingly unsettled way for me. Even though there's a document that has the 12 names on it, there are several documents that have these 12 names on them, and some of them have extra names, and some of them have kind of like crossed out names, and some have imagined figures like a Byzantine god appearing at a certain point. But you know, in the way that perhaps we will talk about, especially also Janna with your work, at a certain point you have to get things down or compose them if you're wanting to make any kind of piece of artwork or any kind of theory or put out anything for sharing. It's a point of composition. And so they reached this point of composition with the 12 figures that are depicted here. And this is a sketch by William Stock, who painted the figures. And so that I was asked to write an imagined conversation between these figures, and the kind of impossibility of doing that kind of quite kind of overtook so much of my thinking, because it became about how to compose someone else's version of history through these 12 figures who all had their own very particular kind of versions of what existence was and meant to them, and who've travelled through time on and through the words of many, many other people. And so I just, all of a sudden, this cosmic oval became like very full of people, and not just full of the people we might know have written about some of the figures here, but also some of the people whose lives touched their own, or whose lives they also affected. And that's, I think, why also Janna, so at one point I cite Janna's work saying, we are in the questions we ask, and I call you an astrophysicist storyteller, but in in this way with the highest regard, because something you do is also you bring in all these figures into the kind of the one story that might travel through our kind of common understanding of a theory or of an idea or of a time, and you gather people around it.
Well, I love that, and I really appreciate that's such a beautiful sort of summary of what the project is. I noticed when reading your book that there's a lot about conversation, not just a conversation that you were describing in the Oval, but the book itself is partly a conversation. We were talking, and also Esther, we were talking yesterday about annotating other works and what a contribution that is. And then if you maintain the annotations, then the conversation becomes bigger. And I had this sense that this was part of this active living conversation. And part of the musicality is that it feels that it's in time. Right, it doesn't feel like a static work. It feels like it's something in time, which is why it was so relevant, the phrasing and the theme of the piece that we just read. But in with respect to how this this conversation started, even the moving galaxies that you're describing were not predicted by Einstein himself, but they were predicted by his theory. So he had to be in conversation with other mathematicians like Hilbert to do the math. He struggled with the math. He kept publishing incorrect papers. And finally, by 1916, he writes down the general theory. He himself does not predict the Big Bang. He does not predict the expansion of the universe and the galaxies moving away, and he doesn't predict black holes. All of those were in conversation with other scientists.
And it comes to this idea that certain ideas have a time in which they can be understood. I mean, maybe ideas are lost, but that there's a kind of potential in the moment and understanding definitely of the capacity, where we've got to in our understanding of the story of the universe,
Well,
where it's led, what we can do, and where the technology, observational science, what the technology will allow us to do. But if you think about, the shoulders of giants that these thinkers stand on, would Newton have come up with relativity had he lived for another 400 years?
I have just one adage in response to this, which is, the more I know, the less I understand.
Right.
I sort of feel that way more and more, that I have thought about these things. I've hit a moment in my life where I had a sense of peak understanding, and now I know even more, and I feel it spiraling away. I understand that it will be revelatory in ways that maybe, like Newton, we won't be here to be part of that conversation. But another small thing, which somebody had to point this out to me. Allegedly, Newton was being unkind with that statement when he said, "I stood on the shoulder of giants," and that he was taking a stab at his nemesis, who was a short fellow.
I stand not on your shoulders.
But that,
He was not a nice guy, Newton.
Right.
He was kind of a terrible character.
but even that, like,
But he was a genius. Yeah. So Hooke was a shorter fella, and they were in competition. And he said, "I have stood on the shoulder of giants," meaning not you.
But that, you see, this is the stuff that I hope comes through in the book, which is like who's telling us the stories of who, and that every figure is as complex as all the relationships that they've had in their life, and how certain aspects of those figures can almost, like, I guess, kind of wilt away through time. I was watching one of the videos up in the gallery about explainer videos about quantum physics and quantum mechanics, and there's a tree between two people talking, and they're talking about like all the branches of existence. And I was thinking, so like on this branch I actually think the person speaking was saying, on this branch you could be having an amazing day, and on this one a terrible day.
Yeah,
We're like putting it into
wrong branch.
Oh.
Yeah.
Yeah, oh gosh. Or like all the branches together at once, I guess. And so this about the the kind of character forming through what stories we choose to tell, and just the sheer volume of stories and speech about any one figure through time. I mean, it's what I cite Hannah Arendt talking about, that people are carried through incessant talk about them. People are remembered if they have this incessant talk around the. So the shoulders of giants as well, like these kinds of almost figures of speech that become these travelling objects in their own right. I kind of love.
Yeah.
The way you've just like opened up another aspect.
I did actually want to ask. I know I have to let Lily has a plan for us, but I sort of, how do you impose constraints to make this incredibly spare object in many ways, with a lot of space in it and an invitation to converse, when there is so much material, right? And I think this idea of constraint is related to the idea that Einstein honed in on one constraint, and the more he pared away and the more he focused, the more the world actually opened up for him. And yeah, I'm wondering how you think about imposing those constraints.
I think that's such a brilliant question, and it takes, I think it takes us back to conversation, because I think it's only through the people who I had conversations with this work about that it became so constrained. I owe so much to Sarah Shin, who read the work and could already see what it could become in the kind of hugeness of what it was before, perhaps less constrained, maybe constrained in a different way, and actually certainly constrained in other ways, which I might not go into. But it's all also about style and form and expectation, and anyone who writes here, we all write differently. But one thing I do think that affects anyone who writes is the time and space in which you're writing, by which I don't just mean like the present moment and what's actually happening in the world right now, even though of course that is incredibly affective, but also like where you write and how you write and where you're taking up space writing. And I write a lot in time that is not really my own, that's taken up on the edge of time, and that job there, or standing next to a swimming pool, or with that might sound really strange, but it's it's like just incidentally where the ideas come, like where I suddenly have a thought. So actually it's quite messy and unconstrained, my writing. And one thing that Sarah said when Sarah first read it was, I was just really like worried about your body, like when I was reading this, like what happened to your body when you were writing it? And that was a really extraordinary moment, because it was someone actually reading something that was very kind of viscerally happening in the writing, because I wrote a lot of it in the night, as comes through the introduction. This is a book that also thinks about knowledge in the night and what comes through when we're like maybe either pressured by feeling in a different kind of state of mind, not entirely wakeful, and also kind of modes of thinking that can have both branches at the same time. Like I'm awake, but I'm also quite asleep. Anyway, so this is the loopy way of me saying that many people who read me would kind of helped me formulate this into something that could actually be read by other people, and people could have a relationship with it. The constraints I set myself were to write in the room that actually, Janna, you've been sleeping in the Cosmic House. I had certain constraints around when and how I would write. And then I always think we're always writing, and even if we're not like actually sitting there doing this, and the moment of composition then happens at a certain point. And that was the moment in the night where, no, I didn't really sleep, and where my body was doing all kinds of mad things. And the constraint came after.
It is a series of reductions in a way, or maybe, I don't know if you'd mind calling them reductions, the sleep songs. And obviously this kind of reductivism is a key part of the scientific process. Sometimes controversially, sometimes not.
Yes, it enrages people for reasons I don't fully understand.
And I think often bridging between arts and science, the kind of creative impulse is a synthetic one in a way, sometimes more than it is a reductive one. And physics is aiming for the ultimate particles that have emergent properties, so they're not uncreative, but it does always seem like you're getting down to the limits. And I sometimes, psychologically find that a bit disturbing, or, and I just wanted you to kind of, as the physicist, defend reductivism a little bit.
Physics is definitely the ultimate in believing that everything can be reduced. If it wasn't so successful, we would have given it up, right? It's unbelievably successful. So the world looks so incredibly complicated. if you look at the 1800s with the Scottish physicist James Clerk Maxwell, who realized that, along with Faraday, that electricity and magnetism were actually one force, electromagnetism. That was the first instance of unification. People might have heard of this attempt to find a theory of everything, the ultimate unification across all the matter forces and gravity. The idea is to write one mathematical sentence, one, and from it everything can be derived. That from the onset of the Big Bang forward, anything that's real can be derived. Getting into reality is actually quite complicated. We could talk about reality with the quantum exhibit upstairs, but that's just continued to work since Maxwell's laws were unified, and electricity and magnetism are in fact different sides of the same coin. The speed of light was shown in Maxwell's equations to be a fact of nature and a constant, which freaked everyone out, and that started modern physics. That unification launched everything that happened in the early part of the 20th century. And after that, we learned that the nuclear forces could all be fused together. Really, all the matter forces get along very nicely and behave themselves and are unified. There's one real theory of matter. We don't know what it is yet exactly, but there really is one from which everything derives. It's not resistant to this. It just keeps working. Gravity is the outlier.
Right.
It refuses to behave, but it's gotten to the point where we now think that's because gravity is probably not a fundamental force. It's probably not a fundamental part of nature. It probably emerges from quantum mechanics. And this is the most modern thinking on it. That if we look closely at, let's say, a black hole, it's not actually a smooth space-time. If I imagine the black hole as like some big shadow on the sky, if I look closely at the quantum level, I will see that it's really made up, almost like embroidered out of quantum wormholes and entanglement. And that the notion of a space-time emerges from that embroidery. We can't prove that yet, and the math is very elusive, but the clues are very compelling that that's the direction we're going.
So you feel like that is...
I can't even remember your question. I was
Well,
going on
about
for
the
so long.
unified... Now I'm interested in that
Started getting
optimism.
dreamy and like lost.
The optimism for the unified theory.
Yes, but this is what I mean. The more I know, the less I understand. I spent my whole
Yeah.
life understanding relativity, and it might not even be fundamental.
Yeah.
And that's both moving and haunting.
Yeah.
So, yeah, I mean, reductionism does not mean the world gets less interesting or that it gets smaller. And the idea of constraints, you know, in your book, you decide to focus on this conversation with Charles Jencks and this specific frieze, and yet it becomes its whole new world. All of these, the greatest discoveries of the past 100 years have all been in an attempt to hone in and make things small, and they have exploded. The big revolutions, like understanding the whole Big Bang, the evolution of the universe, all of these things came out of reductionism.
And Ella, in your book, you say humans have a urge towards the microcosm, which to me also was partly that, although obviously we have an urge to the macrocosm too, right? We're kind of in both directions, but yeah, is that the distillation?
I was just thinking that I answered your question kind of slightly adjacently, because you were talking about kind of compositional constraints, and I was thinking about writing constraints, which obviously are like
It's all, yeah.
I mean, they're all
they're all important.
They are all connected, but I do also think, in terms of also the compositional constraints and just listening to what you were just talking about, Janna, I'm so reminded of there's this thing you say about editing that I have always in my mind about, you know, the kind of loopiness of a book and the book form and what it does to time, where you say, I'm not a psychic, this is editing. And you kind of come out of a kind of a memory and a story you're telling, which is also a future memory. It's a kind of anticipatory memory, which is also, I think, doing something brilliant with time, compositionally. And you say this about not being psychic, but editing. And I was just thinking of that in relation to the embroidering of the black hole and like the clues, and thinking and wanting to kind of ask you a bit, because I am so curious how you also do this work yourself between the kind of different languages that you move across when you write these amazing stories that then illuminate the theories in this way that takes us through narrative and anecdote, seriously so. And then you move to these scientific papers, which in relation to compositional constraints for me and what I was doing, I'm amazed by them and kind of in awe of them, but I have not got the ability to read them. So and I'm just interested how you make that move, that translatory move.
Yeah, I think that we're all translating it from codes to some extent. So this paper I sent you was partly to show how disjoint the languages are, just to be amused by it. So I've been working on these calculations for literally a year and a half, and it's just calculations all over my apartment, all over my office, just everywhere, streams of it. And I would just calculate, and then throw it in the garbage, just stacks of papers. Because once we had it, we sort of had it. It was a paper with 3 collaborators. And then translating it for myself, I have to then translate it. What am I looking at? I can follow the math sometimes, and I don't know how to interpret it. I would say the hardest part of this paper that took us a year and a half was interpreting it, knowing what we had. Number of times I would go to my collaborators, Brian Greene, Massimo Perazzi, Daniel Cabot, just because it's nice to name them, and I just didn't know what I had. And we all looked at it for a long time before somebody would say a word that like dislodged it. The whole thing would kind of crack open. We'd go chasing it down. So I think the translation is because we all have to translate all the time. I mean, you're translating in this funny script where we have vowels and consonants, and it's a code. It's still a code, and it's a code with quite rigid rules, and the rules are beautiful. Right, and it's only with the rigidity of the rules that we play around that scaffolding and musical notation. But music is also beyond the notation, is very formal, very mathematical. So I think we're all doing it. It's just kind of a matter of how much.
And what we choose to use to describe these things.
Yeah, and right, which one of those we do. So I love deep diving on the math because it's what gives me confidence. It's what makes me feel most profoundly connected with the whole cosmic story. And that's why I do it. But ultimately the goal is to translate.
Yeah, and those translations obviously then turning into words that we use to describe science. And Ella, you mentioned, I think it's in your book, you mentioning about the certain metaphors that we use for science, describing science, particularly around Big Bang, black hole, dark matter, dark energy, the kind of words that sometimes hit the mark and sometimes don't, and obviously carry some kind of cultural baggage that lingers amongst them. And maybe you can...
And carry stories. I mean, I'm so compelled by this that just every word has a whole incredible storytelling cosmos of its own. And even a question actually that Lily had asked a few days ago, and that has been on my mind now for a couple of days, and I've been trying to think of and not really getting very far, kind of loopy answers of my own, was something about, is the work mathematical? Yeah. And to answer that, I had to really look up the word mathematical and get inside that word. Oh my God, what an amazing history that word has. And so now, like, I'm full of also the kind of, but was that right that I read online? Did someone just make that up? Like, but, kind of questioning all these stories that I've read about the term mathematical, but that also, and I'm sure there are people in the room, and definitely Janna will know much more than me about this word, but part of its root is about learning. And I found that really moving, and actually kind of and then I thought of myself at various kind of ages as a learner, as a student, and I think I always am a student. I think I'm always learning. But actually, you know, my own relationship with what mathematics meant, you know, what it does, what education, at least in the UK, does to reduce such a term to such a formulation in terms of relationships of curricula and a kind of actually, I guess, something that dulls that subject. And it's really exciting to me, actually, as just a segue, that there are teachers who I've met, maths teachers who I've met in secondary schools now, who teach philosophy on the, you know, at the end of the maths class. Like, that to me is just so exciting, and I kind of, so that was the long answer to the words, because every word, and I think this was why this project seemed so massive at the beginning, because every one of these figures came with all their own histories and their own kinds of, I guess, you know, ways of being written up, their own definitions, like what are they? Are they a mathematician? Are they a physicist, a theologian, a historian, an astronomer?
And we used to be less stark about those distinctions. Yeah. But also, just you're making me think of something, if you don't mind, if I just reply, is that we've learned how precisely language can be mathematized with the advent of large language models. We have always known this, but I think now every day people are now interacting with mathematization of language, and all those large language models do is collect what we've produced, which is just really drives home that we're all doing these mathematical problem solving exercises or all the time. It's just that we don't all feel comfortable formalizing it so specifically, and it has never robbed creativity, the fact that language is, I really believe very much that language is a mathematical structure, that whichever language you're studying, we know when people are making mistakes, and even if you really speak a heavy slang, you can make mistakes in that slang and it's laughable if you're not doing it right. You know, it's not a social, the idea that there is this human vague thing, that it isn't this incredibly precise collection of operations, I think is untrue. And yet the creativity that we see in language is indisputable, and it's irrepressible. Right? It's utterly irrepressible. Every generation that survives on this earth will experiment with language and poetry and song and conversation, right?
And maths.
And maths.
So how do you think of it in this? So I was trying to think about this, like this relationship between language, like I guess, like building blocks of language and building blocks of maths. And how does then that work or for you? I mean, this is just thinking out loud in relation to, say, 1 + 1 moving across many different, I guess, societies and cultures, and we'll presumably have a shared understanding of 1 + 1. But a word in one language would have to move through a translatory process that would unpack all these like huge myriad meanings and then have to be put back together again somehow.
Yeah, I think that's so complicated.
I'm sorry. Yeah,
no, but it's so it's so beautiful that we know that some languages are better for certain expressions than others. We know that English is incredibly popular for writers, even non-native speakers will choose to write in English, and yet some words don't translate well. We all know this experience. There's not quite the same single word, and any great translator also comes across this all the time. One thing you mentioned about maths, I just have to say, it's not plural in America. We only have, so I actually prefer it as maths. A friend of mine once said to me, like, there are different kinds of math? It's like, oh yeah. I mean, there's math that I don't know, you know? And somebody can make up a new math tomorrow. It's almost like making up a new game like Monopoly. you can invent mathematics. So anyway, that's also to say that the math can get, like translating between verbal languages, sometimes we're translating between mathematical languages. So I had done a lot of the calculations in this paper, and then one of my collaborators started talking about it in a completely different kind of math. Literally invoked a completely different kind of math to discuss it. And it was also kind of devastating because it was opened up a lot, but it also was so hard. It was so hard to translate between them. So
Janna, we've got to talk a little bit about, for the audience and for all of us, a simple way, your paper, because you've mentioned a couple of times now,
sorry.
and it's about a fascinating topic. So that I think, if you can tell us a little bit about the paper.
Yeah, I meant to send it to you as a joke, and I meant to send it. Really, I thought I should send this after the conversation so I don't derail everything, and now I've derailed everything. But I'll just say quickly, we're exploring the possibility that the universe has extra spatial dimensions. So we know we live in 3 spatial dimensions because to find each other, we had to decide where we were up, down. We were down a flight, where we were north, south, and east, west, 3 spatial dimensions. And we also had to specify the time. So technically 4 dimensions for space-time. But a lot of people suspect that there are extra spatial dimensions, and I suspect that there are. We don't have any proof of this. It may not be true, or it may be that the dark energy that we see in the universe, which you referenced, is evidence of these extra dimensions. So we were looking at something called a Klein bottle, which is a very interesting and strange shape. You take a left-handed glove on the Klein bottle, and it comes back right-handed. And this chirality flip was something I was particularly interested in because the universe is largely left-handed, and we don't know why.
Right. Unlike most humans.
Unlike most humans. And some forces interact only with the left-handed version of things. So I was kind of imagining you could go into this space left-handed and come back right-handed, and you would technically be invisible.
Right.
And so that could be like making dark matter. Yeah, I was trying to make dark matter by like a ray gun going into this extra dimensions and coming back invisible. Because dark matter is really not dark, it's really invisible. It's in this room, and we don't see darkness, we just see nothing. And it's passing through you right now, and the dark energy is in this room right now, and it's invisible.
Sometimes you use a straw to describe how that extra dimension might work, but could you just maybe use my pencil?
Yeah, so in the idea of an extra dimension is, so if this pencil were really, really long and I lived on this pencil and I was a small creature, I might think there was only one dimension, that there was only the length of the pencil. And as it gets smaller and smaller, you might think literally there's no width, there's just, and no height, there's just this one dimension. But if it got fatter and fatter, you would start to notice that, oh, I can go this way round. That's two. This one technically is really only one extra dimension if I stick to the surface, but it's compact. If I walk in a straight line, I come back to where I started. And so we're looking at compact spaces like that. So like this dot in the room would actually be wrapped up kind of like the pencil is. And it's just very small, so I don't notice it's there because I can't stick my hand in it. We were actually looking at different models than this even, where you have a large dimension. I'm going to give that back to you because I'm very clumsy. Where you have a large dimension, but we are glued to a 3-dimensional membrane, which we call brains for short, floating in this higher dimensional space. So this Klein bottle could be big. We're like glued to this membrane, and this membrane travels through the space.
And when you say we, what scale are we talking about?
We're talking the entire universe, all the galaxies, Ella references, everything. You know, there are hundreds of billions of galaxies as far as the eye can see. All of it, it's a 3-dimensional membrane, is traveling through a higher dimensional space together.
Yeah, great. Got that, everyone?
I mean, it's possible.
And will the scientific paper then make it into a piece of work of yours that is?
Oh yes, that's a great question. I will probably write a piece about it in English.
Not maths, or like
Yes.
pure maths.
Yes, I actually really want to do that. Because I don't think I'll fully understand the paper until I do.
That's really interesting to me. Well, so because I love how you was talking about these kinds of piles of all the kind of equations or working out and all the maths around you in your apartment. But then, and it makes me think about how we understand, like, and when I say we again, it's like, well, I'll understand differently from you. Of course, I don't really understand that paper at all. And when you just said brains, I was like, oh yeah, I remember that, but I didn't know what it really meant. So
and
then
it triggers folds and
Yeah.
thicknesses and I mean.
but so what does it take then? It's a different kind of understanding then.
Yeah, I would say my collaborators understand it differently than I do too, right? So that's also, we're at the edge of all of us, right? So in a way, I'll never fully understand it the way they do, maybe, or vice versa. And so where can we go but the conversation, right? Which is, again, what you're inviting and what you're participating in is the conversation.
And well, thank you. And also, when you write these books that kind of bring your own theoretical and practical research into other kinds and forms of language, then what's that process for you of understanding newly to yourself?
Yeah, I feel, I mean, I am such an admirer of the written word as well. I think I knew that about myself before I knew I could do math at all, right? I mean, I kind of discovered math and physics midway through college, so it was pretty late, actually. So I think like the frieze or like the conversations that your father wanted to not only encourage but continue. He wanted these to be lifelong conversations from what I'm understanding. And I think it's just this kind of notion that it is lifelong. Yeah. It's just lifelong. And also, I guess what I wanted to say also, you were talking about Hannah Arendt and all of these figures and how the conversation about them got away from them. Yeah. Right? It was no longer, they were no longer the sole source of the conversations about themselves, right? But also that these silos are so artificial. No one is born, these are just artificial silos we've imposed from the social structures that we have right now. Yeah. The word scientist is fairly new. Yeah. I don't think the word scientist existed when Newton was working. Maybe somebody knows that history better than I do. So there's a notion of being so siloed is so extreme right now, and I do feel that we're coming back around to challenging that, and at least here in the West. So I don't know. I don't think I'm born a scientist or born a poet or born a These are just all things we're struggling to integrate to understand the world.
I mean, I so hope for that. That I guess that permission. I mean, I wonder also so much, and I wonder this while I'm teaching, about the kind of spaces that we move through at very early stages of our lives, through education, in our family, like in our wider social circles as we grow up, in our communities, like who in those or what gives us permission to also be able to cross over the quite siloed disciplined areas of science and the arts.
I'm going to turn now to, we have a formal respondent, Tony, who's a Scottish philosopher, and let me. Oh, maybe they're stuck together.
Thank you.
Is that okay?
Yes.
Great. Tony's a Scottish philosopher. He's a I have to get my notes, but professor of ethics. Is that right?
Well,
In the Visionary Cosmologies project at King's.
A researcher.
Researcher.
Let's demote me for the purposes of today.
And we asked Tony to give a formal response today as a way of also inviting questions from the audience. And so after, we'd like to open up.
Okay, and I'd like to thank you for the introduction, particularly the introduction, not just a philosopher, but a Scottish philosopher. And
I think we
Very
would have
good.
gotten that at some point in the.
and strange, yeah. There's a wee hint. So if I'm speaking too low, then raise one hand and I'll speak louder. If I'm not speaking sufficiently Scottish, then raise both hands, because that can be managed as well. It's entirely within the capabilities. So there's an oddity about connections and the things that we think of as separate from one another. A number of years ago, about a decade ago, I decided that, well, I've had too much noise, too much controversy, so I'm going to write a quiet wee paper. I'll write the paper about helium-3. Nobody can take offence at that. So I look at the practicalities of mining helium-3 on the moon. At that point in time, they didn't look good. Now they look better because the use of helium-3 to cool down quantum computers is crucial, and it makes a difference. So I wrote this paper saying, look, you're going to have to destroy large amounts of the surface. And I delivered it over into Reno. We were all in the conveyor belt. It was 15 minutes, and I posted the paper to Academia EDU, which obviously is a great provocation to the world. And the next morning, there's newspapers. Scottish philosopher says that mining helium-3 is evil. I couldn't decide whether they took offence to my points about helium-3 or to the fact that I was a Scottish philosopher. That seemed to strike them in particular. But I had imagined something, a disconnection, which was not there in other people's minds. And this theme of connectivity is fascinating from a philosophical point of view, particularly if you're interested in things such as cosmology. So when I was reading the book, I couldn't help be struck by something that speaks to me very much, which is that here you have this text, and then you have these poems that come afterwards. And I thought, this is a very old, this is 1,000 years or more format. This is a style that's been done before. It's particularly within the Zen tradition of Buddhism. It reminded me of books like the Gateless Gate, which of course you all have by your bedside, but for those who don't, this is one of the classic books of Zen koans. And they go through a koan, and then there's a verse where you try and capture the simple idea in a very simple way. And the great book of koans starts with a simple question, which is, does a dog have Buddha nature? And you think, well, if you're a Buddhist, if you like dogs, you like all sentient beings, of course a dog has Buddha nature. But actually the response to it is not that, is mu, which is nothingness, which is denial. And the thought here is that it's a mistake to imagine an individual sentient being disconnected in a radical way from all other sentient beings. In the standard reading which has emerged, I won't go into the literature of it, Dogen and a variety of, if anybody wants a list of a pile of books that have been written in the 20th century about this topic, then I can give that to them. But the basic thought here is there's a denial of interconnection, which is built into the very question. But the difficulty, of course, is how we accomplish that understanding of interconnection and the fact that we're really not at a fundamental physical level. We're not separate, these beings that we imagine ourselves to be. How can we accomplish that in a disciplined and thoughtful way that doesn't start to sound like we are sort of refugees from the 1960s who think, man, it's all really connected, or something of that sort. And the kind of reflection that I've found in the book is very reminiscent of that way to tackle those two problems. How do you address interconnection and traverse the boundaries between disciplines, reaching over into the math and the physics, but how do you do it in a disciplined and plausible manner? Okay, well, you've had enough of the Scottish philosopher just now, I think, so I'll sort of hand it over. But just a bit of a personal thing. did any of that stuff, that Buddhist tradition of was that anywhere in the background of your mind? The story, the case, and then the capping verse that comes afterwards?
I think it's such a brilliant question, because something that I said that I wanted to talk about, but actually we're getting to the end and I haven't, is about citation that is almost quantum, in the sense that it doesn't necessarily appear in the book, in any book I'm talking about, in explicit ways. So, for example, could appear in acknowledgements or in epigraphs, or just in the mind of the writer, and then maybe it comes out in talks, or maybe it comes out in a talk like this, how absolutely kind of instrumental Janna's work is and influential in such a book, where, for example, the amount of citations would not necessarily tell you that. And so in relation to like form and style, I mean, yeah, we could go into a whole kind of conversation about that, because for sure there are kind of traditions of style in here that are also borrowed from some of the 12 that are in the oval. There's also and I was thinking of this person a lot actually while writing, and actually in relation to Janna, playwright. There are a few kind of playwrights who I greatly admire, who also do this kinds of constructions of kind of redacting and reducing and distilling, and then move into different kinds of verses or different parts, or have different versions of the same story but in different stylistic forms. The playwright, by the way, I was going to mention is Susan Laurie Parks, and who I think you and Susan Laurie Parks would have an amazing conversation, because Susan Laurie Parks went to study physics, I think, after being told that she couldn't spell, so she shouldn't do writing, but she really wanted to do writing, and she took an extra writing course while she was studying physics, and she took it with James Baldwin, who was like, have you ever thought of writing for the stage? And she was like, And she's an incredible playwright. But I mentioned this kind of adjacently because form, and I guess this comes back to constraint, was so integral in terms of how I could, I guess, place or compose my ideas. And absolutely what you're saying in terms of the kind of the Buddhist kind of distillation, but also what I would call a kind of turning to face another reader or to face another audience, or maybe I can tell it this way and pull this kind of attention from you, was very much in my thoughts as I was writing across quite a few different traditions. One of the 12 in particular I was thinking of was John Donne and Abbot Suger, and then into also Hannah Arendt, whose work in Charles's library was very heavily annotated. So I also had her work with Charles's distillations. So it moves through all these different forms of address as well. That is such a long answer to your question. Thank you for asking it.
Thank you.
Thank you, Tony. We'd like to open out now to the audience. We've had a very broad conversation today, but we'd love to include you in any questions to anyone on the stage.
There's a question over here.
Great. Let me give you one. Great.
It's a question to Ella, but it's very relevant to the rest of the panel. Philip Pullman, when he was writing Dark Materials, spent lots of time in physics lectures, and the big thing that he came away with was phase space, which means very different things to very different people, but because of the nature of the story he was writing, it was something that enabled him to finally complete the lifetime double trilogy. So I wanted to ask Ella about that, and whether you encountered it in any of your conversations and what it meant to you.
How amazing! What the story of Philip Pullman or Face Space?
Yeah, that's his, I'm quoting his creative
process.
He wrote children's stories and stuff. But he had to get a bit more detailed with what he was doing in Dark Materials. And he knew the fantasy, but the society was like, okay, I better find out. So that's what he did. And in Oxford, sorry, thanks.
Yeah, I mean, I think that's wonderful. I would also, I'd be interested to, to ask, I think this is also about kind of influence as well, and inspiration, and who you go to kind of, I guess, to learn from and become a student again. I mean, I remember like early on, early days, and I have to also say that this goes back to what I was saying about, the worlds we move through at young ages and our experiences of education and what we pick up along the way, because I come from a family who've been also very interested in these things, these such questions of existence alongside me. And I met Janna when I was, I think, a kind of awkward teenager. Definitely.
I don't remember the awkward part.
Oh, right.
You felt it.
Yeah, but I think it's because it was, meeting you, and already feeling like such admiration for this person who was dealing with things that I could, that were completely mind-blowing and expanding and still are. And so when you say about like going into physics lectures and stuff, I really love that, because it's like stealing into the other discipline that you're not necessarily kind of, meant to be in. But it comes back to the silos of breach them. And I'm interested as well, Janna, for you, like what, because you studied philosophy before.
I did. I hated it. I hated it so much. I'm so sorry. I finished an entire degree in philosophy, but then I double majored in physics and astronomy, and that's what I ended up going to graduate school in. But I'm going to spare you my sob story. But what drove me crazy, okay, I'm going to say it. What drove me crazy about philosophy is we were still arguing about what Kant meant. And it drove me out of my mind. I was like, it can't be that important then, right? Nobody was arguing about what Newton meant. He told us, we used it, it was ours, we could teach it to anybody else. And there was this egalitarian aspect of that was so powerful. But I do want to, may I address your phase space question? So your father talked about strange attractors. And in some of his landscapes, he was using these things called strange attractors, which come out of chaos theory. Those strange attractors are in phase space. They're not necessarily in physical three-dimensional space. So phase space is if I choose to plot, I could be in many different senses, but I choose to make a space of momenta, not spatial locations, let's say, or I could have both. I can, have very, very high, very large dimensional phase spaces. Anyway, so I just wanted to make that connection with the landscape and your father's work, and it's all over the Cosmic House as well. This idea of a strange attractor in phase space.
And Tony, I just want to give you a chance to have a philosopher's moment.
I'm so sorry.
No. It's.
I also have no filter. Like the frontal lobe is not fully operational right now.
No, what's kind of annoying about what you said is that it's right, and it would be less annoying if it was wrong. There is a perennial aspect to certain questions, and about our connection to the rest of the universe, and we think that we've solved it for a period of time, and then it's like the bump on Tom's neck, the cat. You push it in, and it just reappears somewhere else. And part of that is the elusive nature of the problems. And even when you provide a formal piece of work, so you do the math on something, and it looks like a solution. And then there's the business of taking a step back and say, well, what does the maths show? What does it tell us about the nature of the universe? You even get that. You get that especially when you start speaking about dimensions and about the kinds of spaces that mathematicians look at. I love the wonderful story about David Hilbert going along to a lecture about Hilbert space and asking the question, what is Hilbert space? In the hope that the speaker would actually provide a simpler answer than he had.
Yeah.
And
yeah, I do think that there is a trend. I think my objection, everyone laughs at me because I'm very philosophically leaning. And it's all over my work and it's all over my writing. And so it's this, it's like this thing I've been resisting my whole life, fighting. Many of my colleagues are winding towards philosophy more and more. And I think it was part of this, the more I know, the less I understand phenomenon.
Could it be, as academia's come up, when Tony, thank you so much, by the way, for responding to this. Could it be, I wonder, though, that something about, and this is just a provocation, that something about the academicization of a discipline or a whole incredible, wild area of thought actually does something in a kind of containing structure that does dull it? Because I'm also thinking of teachers and like the incredible way that certain teachers can make you love and want to study any subject, whatever it is. And I was thinking about, back to your question about Philip Pullman going into certain lectures, and I then thought about you, Janna, as a teacher, and just thinking, like, it must be so incredible for your students to have you in the space. Because
they didn't feel that way after the midterm. After the midterm, they practically walked out.
Well, I mean, okay. Well, I mean, I'd love to be one of your students. But I guess this is also about how you are philosophically leaning. You're also a poet. You're also incredibly lyrical in the way you talk through science and existence and through, this hard maths that's in that paper, like bringing that to us in a way that kind of unpacks it, expands it, and makes it complicated again. We don't have to understand when we read your books. It's not kind of thrusting it down our throat to like, you will get this. It's an invitation to study with you.
I actually love that. I think it is okay not to understand everything. Even works of art that we love. I think in some sense that element of incomprehensibility is part of the attraction. It's part of the attraction to very deep, long-lasting works. I think a lot of that is about proportions. I had one physics professor tell me every talk on physics, one of my MIT professors, Walter Lewin, said every talk in physics should have something everyone can understand out of respect for the audience, something only a few people can understand out of respect for the experts, and something nobody can understand out of respect for physics. And that's kind of my philosophy of everything that I try to do.
I'd love to give an opportunity for anyone else in the audience to ask any questions. Thank you.
Hi, thanks for that. I just have a question for Ella, and how you found the voices in the 12 characters that whether you found any characters harder or easier, or whether you had any surprises when you went into more depth.
Oh my gosh, that is such a brilliant question. But you know what? That is also another, let's have an hour conversation. Let me think if I can distill this. As you've probably realised by this talk, I'm very bad at I go on tangents. This was part of the impossibility being, in conversation with these 12, and I quickly realised that everything I was reading about them, and from very good sources and some from the more evil side of the sources we now have. No ChatGPT, but certainly Google. And I think there's one point in the book where there's a kind of list of different descriptions of caves, which came from a kind of late night Google search of did Pythagoras live in a cave? And it was like many caves, one cave, collection of caves, no concrete evidence, a cave. And I was just like, so that's only one source is Google. And look, we have it now. In my lifetime, when I was born, there was no Google. And so this is a product also of its time and what I could find in terms of all as much literature as I could in the time I had, because this is also a time-bound object. One of the people I cite in this is Marguerite Yourcenar, who wrote a book called Memoirs of Hadrian. And in her incredible compositional notes at the back of the book, which are just like worth getting the book alone for these compositional notes. She writes about how she started writing it as a young woman, and she kind of left it, and then suddenly discovered the manuscript again some years later, took it up again, took it on a kind of wild night train ride and started writing more of it again. And one of the things that emerges from these compositional notes is time, like taking time with one figure to get really inside. This is Hadrian. So Hadrian is one of the 12. And I read Marguerite Yourcenar and I just thought, it's an illusion that I could make any of these people come alive in any other way than a kind of stage set play. And I could have done that, like, Pythagoras saying, so how's it going with your, how's it going with your pyramid?
With your theorem.
Yeah, like, how are the mastabas going? And I just didn't, it's like I couldn't dramatize them, because there's something about a permission for me about dramatization that I would want to do more work. I would want to, not like that I would ever fully know any one of these figures, but I would want to spend more time with them. And that's why I write in the book, Hannah Arendt is the figure I've spent most time with, because it would make sense in some ways in the time and space that I'm living in and the disciplines I've moved through. I have a very odd relationship with universities and disciplines. I've moved through so many. But that Hannah Arendt would figure as someone who would come up again. But did I know her? No. Like, I started reading her work. I started reading around her work. Any presumption of ever having known Hannah Arendt or her work was immediately dispelled. And so it's such a brilliant question for the fact that each of these people, each of these figures appear just through what I call shards of what they left to time. So it might be their words, but Pythagoras, I mean, we don't have Pythagoras' words, or do we? I don't know. But whose bodies do Pythagoras' words travel through? So they all appear through either their cited words or through others' citations of them or descriptions of them. And other people then appear as well in the sleep songs too, who are associated.
Can I ask Janna, because you've written a novel that is an imagination of could you describe it for us? How?
Yeah. A Madman Dreams of Turing Machines was about Gödel as a character in that book. I tried to write that book. It's about Alan Turing and Kurt Gödel. And Alan Turing famously, especially here, was the great genius who imagined a computer could be a machine. Computer, of course, was what we called people who computed. And so it was about Alan Turing and Kurt Gödel, but I think it was also about this struggle of Platonism. Is math invented or discovered, and what is real? And Gödel, who is lesser known, we talked about his relationship with Einstein. That was just a tiny, 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 tiny side thing that he did. His big contribution to mathematics was to realize that there was no mathematical theory of everything, that it was unattainable, that there were facts, even among numbers, that were true but could never be proven to be true. And I don't mean like, it would take too long for human beings to process all the facts. They were unprovable formally. He proved they could not be proven. Those are called the incompleteness theorems. And it was so, the Pythagoreans also kind of went crazy. There was like a whole bunch of them. They were like a cult. And they lost their minds when irrational numbers were discovered. And Gödel did something similar. It was so undermining to the whole program.
No, it's just, is it the aphorism that you say, I am a liar? That means both, I am a liar,
right?
And I'm not a liar, but I am a liar, but I'm
right.
not, and you can never.
Right.
Yeah.
But you can argue, well, that statement wasn't made precise enough. Here in mathematics, it was absolutely a relationship among numbers that he proved. It was so ingenious. I'm not sure if I can do it very quickly, but he basically took a statement like that. This statement is a lie, yes, which was his version of it. And then he fully mathematized it, so it was strictly an equation. And the equation encoded statements about itself, that you could assign a code to theorems in algebra such that this mathematical equation was making a statement about theorems in algebra. And that number that corresponded to that theorem did not exist in the list of theorems. It's a little slippery, but he did lots of things like this. He also proved that using Cantor's work, well, Cantor really proved this, that there are some infinities that are bigger than others, very Animal Farm. Well, anyway, so the novel is, you ask about these things because we are human beings doing these things and we emotionally react to their realities. The Pythagoreans losing their minds over irrational numbers. Gödel fairly well was insane and institutionalized and starved himself to death.
Turing had a tough time.
Turing had a tough time, was rather sane, neurologically diverse, but in a way, he's the most balanced of all of us. So I think it's about the struggle when we discover things. And in particular, that was about how we can't prove things through math all the time. And even a biography would have deformed the reality. And I think at one point while trying to write that book, I had 150,000 words or something insane, and I threw it away and started a novel because I felt some things are true that can't be proven to be true. And that was kind of the story. I had to try to remember the book. Sorry, it took me.
Thank you. Do you want to respond to that? Is it
Oh yes. There are two questions here that particularly spark me. One is who survives as the great influence. You take someone like Hannah Arendt, and philosophy in academia has its strange attractors as well, and we can bounce around a lot, and then we come up against social circumstances where questions of truthfulness in political life, questions of the place of love in political life, and all of those things that interested Arendt keep coming back. So, I think she's a great choice. I think Arendt's the most important philosopher of the 21st century, which is no mean accomplishment considering that she died in the previous one. But it is a question about whose name survives and what influence survives. We may not have Pythagoras' words, but we have one of them, which is cosmos, which survives through a hostile source. When Heraclitus, who doesn't like Pythagoras at all, as a human being or as a theoretician, repeats that phrase, and so it ripples down through time. And that's that whole question about what survives over time and who you focus upon as individuals. And certainly someone like Arendt, but also Kurt Gödel. That's Kurt Gödel. If you think it's complex understanding that problem of incompleteness, you should try and read the title of his paper, which showed a genius for public communication, which is on formally undecidable propositions in Whitehead and Russell's Principia Mathematica and related systems. That alone would
Poptastic.
get you. Yeah. That's really hitting the spot there. But the oddity about it, the paradox about it, is that at the same time as showing the boundedness of what maths can do and can't do, that paper is one of the towering achievements of the last 1,000 more years of mathematics. It's one of the single greatest accomplishments in the history. And that's no exaggeration, just because I like people with glasses, and his glasses were much thicker than mine. But it is this towering accomplishment, and so in 1,000 years' time, or in the length of time between us and Pythagoras, if you project those into the future, we will still be speaking about Kurt Gödel and his accomplishments. Whether we will be speaking about Arendt is a different matter, but certainly for this century, she is the political philosopher of this century.
Yeah, I think that's absolutely true. I do want to make the connection with Turing, because I left that hanging, but Turing was so influenced by Gödel's work. I talk about the conversation across space and time. They were contemporaries, but they weren't working together. That it was Turing thinking about mechanizing thought in reaction to Gödel that led him to think about uncomputable numbers, which as they sound are, now we would think of them literally, they're numbers where you can't write a computer code shorter than the number itself with its infinite list of digits. That led him to think about a computer, the idea of making a machine that could exercise these mechanical operations. And it also led Turing to believe that we were machines, in a sense, biological machines. And we're on the cusp of fully realizing, ever since Turing, this idea of the convergence of machine and biology. And that's, I think, that's really what this century is going to be about, clearly.
I think we should call it a day there, because that is an incredible moment to think about, looking back, but also thinking about what the future will hold, and this crossover between the different sciences, physics into biology, and into the arts, and situating us in that. So thank you so much. Well done to the panel.
Thank you. Thank you.